Yeah, there we go. Just a moment. Idea. So we're here. Just want to share my screen. Gucci. Gucci gang. So yeah, so what's the story, my people? What do you guys have?
Nothing.
Really? Nothing. Come on, bro. And now?
The slots I have.
Okay, so what do you have? So first of all, I want us to, okay, fine. Let's see what you have. Let's see what you have.
No, let's do it with you there. I think it would be nicer with you.
So I'm saying let's complete the first method, right? We have your draw state. I want to know first of all, how do you want to? I'm going to remove this code actually. The one that we have here. How do we want to represent our slot? What data structure are we going to use? Why are we using that data structure? And by data structure, I mean like your object. So if you want to use a string, you want to use a list, you want to use the tuple, you want to use whatever, right? So why choose what you want? Why choose that? And or which one should we choose, right?
Okay.
Yeah.
Looked at a dictionary.
Okay. Why?
Remember, with a dictionary, like the time we would have things like, let's say you have your key and your value, and then
Okay.
as you go, you
Yeah.
can keep replacing your values using your key.
So what's your key and what's your value?
The key will be the numbers. Let's say the positions. Let's say.
Okay.
Let's say for, you see the way that thing, it has nine positions, so you can use 1 up to 9, the same way we have.
So you want to use 1 up to 9. So you want to have so I'll call this let me call it, what should I call it?
I don't know, board or
I'll call it board, right? So you want a dictionary where you have one, and what's the
that will be nothing at this stage. It will be nothing. That
what
the value will
represent
be empty. The value will be space.
Space.
Yeah.
So you want to use
just do a string a dash. Yeah.
Okay, so you need that, and then you want to go.
But put them in a sort of a line, that makes sense.
You want to do this?
Yeah. No, 1, 2, 3, then 4, 5, 6, then 7, 8, 9.
Okay.
So I can, yeah.
You want that? You want 8, and then 9. Okay.
Yes.
Cool. Yeah. So you have your board there, and so since you have now you have your board on your on your, yeah, you have your board. Now you want to draw the contents of your board to the screen, right? How are you going to do that? Yeah, how are you going to do that?
So they're on line, okay,
Line
okay,
11.
I don't know if we should 8 and 9 and 10. We'll do print functions there.
So with this one, we're just leaving it here so that we can.
Okay, then go there, bypass.
Yeah.
Then you can do the printing of the first line.
Okay, print. Yeah.
So the first line we will put. Okay, we call in the value for board at position 1. So we say board, and then you do a square bracket.
So yeah, so we're not just think we're using this slots as our board. So we're not using. So you need to pass your function. You need to pass. So when you run this, you would do this, right? And then you pass the board, right? That's what you want to do, right?
I'm not so sure there.
No, that's what I'm saying to you. That's what we will do. So that means here inside this function, we don't use board from outside, but we use slots, right? That's what we want to use.
Okay.
Yeah.
Okay.
So yeah.
It's gonna be slots.
Yeah.
And square bracket 1.
Okay, 1.
And plus.
Okay.
Yes.
Okay.
Then you do a string and then you put in that straight line. That vertical line, what do you call it?
Yeah, a pipe.
Okay, yeah. Then you do plus slots 2. Then plus the pipe. Two. The other one should be 2.
Okay.
Yes, then.
That's what you want.
Yes.
If I do that, and then I pass on board there, I'm just gonna. I think that should be better. Nope, wrong one. So there, so you do have your board, right? Okay. Huh?
Continue.
Okay. But so one thing that we're missing that, right? And right?
Okay.
Because we want it to be that way, right?
Okay.
So we have our board. So yeah, just ask your question, because not.
I was about to suggest that you do that. Put the lines on the left.
Okay, yeah. So this is fine, right? But before we can continue, what if? What do you see that's wrong in this code? Or maybe not necessarily wrong, but let's say we had 100 slots. What would you do?
Okay, it will be difficult to do that print so many times.
Yeah, right.
Which means you should have made that print function.
What?
No, go on. You were saying.
No, I'm saying yeah. Since if we were to have 100 100 slots, how would we do it? Hmm? Do you guys have any idea? What's Nachi?
Oh, I'm looking through something right now. Trying to.
What sound is that?
If we have a lot, then that means we have to have some kind of for loop.
Yeah. And how would you structure your for loop? So for what?
For slots or for
Okay.
um,
For slot?
in range.
In range? Yeah.
Yeah, man, does this thing still have to be shaped like this?
Yeah.
My goodness. So, how do we make it? We gotta have three, and then we gotta go down a line.
Okay.
Yeah, trying to think how that works. So, the function. We might have to group each row.
That's fine. Let's how you want to group the rows.
I don't know yet.
So now let me suggest something, right?
Okay.
So let's change. So I'm going to call this I'm going to do this, right? So this is X solution, which works, right? Works fine, but we need something else, right?
Okay.
I'm gonna remove that, and I'm gonna remove that bit. So for this, so this one you're using a what's this? You're using a dictionary, right? So my data structure would be so I'll call mine matrix, right? And then it'll look something like this, right? And then I'll have something like you see there. So I will go something like for row in slots, right? Right? And then I'll go for marker in row. Does that make sense?
Okay.
And then I'll go something. So before we structure it correctly, I'm just going to say, actually, yeah, that's what I'm going to do. I'm going to say, okay, for slots, I guess it's fine. I'll call this line equals to that. Then I'll say line plus equals what's this? Plus equals marker, right? And then here I will print my line, right? Before we construct it, so I'm going to try and run this, and then I'm going to go my matrix. Okay, now we have that, right? We have 3 lines, 3 lines, 3 lines. So what we so we know that, so like let's say if I structure my line like this, so I know each line starts with that, right? So we know we have the pipe, we have the first pipe, right? Now if I run this, we have the first pipes there, right? Yeah, and then after each one I can just go plus that, right? And then
Okay. Isn't there a neater way of doing that?
what do you mean a neater way?
I'm thinking right now.
This probably should be the neater way.
No, it's fair. I'm gonna remove this because we already.
Can't we use okay, but the join function is only gonna put them in between.
Sorry?
The join function. The join method.
You could do a join method, right? Yeah. So you could say for each row, right? So for each row, so let's have another one. I'm going to, okay, fine. For each row, I'm going to do this one with a matrix, right? This one is just another one whereby you want to use for each row, right? You want to say print row dot, actually, nope. You want to join, right? Then this will miss. So you see this one has.
They'll miss the ones on the outside.
Yeah. But you can always do this, right? I mean, say line equals to right.
Okay, you haven't called.
Right.
Yeah.
That's another way.
Yeah, fewer lines.
Yeah.
Yeah.
You see that, right, Jack?
Okay.
So yeah, it's fewer lines of code, same result, right? So now this one will work even if we had like a 9x9 or a 20x20. This will still be fine for us, right? Because you won't have to use this method. So you're fine if I remove this one, right?
Yeah.
So move this one. So we're using, and then we're going to use the one that.
Don't remove that one.
Yeah, I'm not. I'm commenting that one out. Right, so we can use that. So we have our board, right? So now, actually, before now we have our board. Now I want to create another method. I want us to generate our initial config like that, right? So now we have this, which was manually written, right? Like I said, now if we were to use if we were to use a 9x9 or 20x20, like I mentioned before, we won't be able to do this because we can't write it manually if it keeps on getting bigger and bigger, right? So how would you write a function that will generate a configuration for the initial tic-tac-toe board, right? So like, yeah, this is the function that I am suggesting. The name is called generate initial. And I want you to give me suggestions on how to continue with that. So one thing that we need to use is the size, right? The size of the board that we need to generate, right?
Okay, so
Mm-hmm.
I think you'll have to do 4 loops, right?
Okay, so you want me to do a for loop for, yeah?
Let's say for row in size.
For row.
Oh, you have, yeah. Let's see.
For row in, yeah? But row is a number. So this is different because the other one, with this one, we already have the board, right? And we are just going through the board, right? With this one, we are trying to generate the board, right? So
shouldn't you have
yeah.
another for loop for
Yeah.
the number of columns?
Okay, so you want me to call in what? Why row? But row is a number. You can't say for this in a number, right? What's the size?
Range size. Range size. The column has to be the same size as the rows.
Yes, because we have an n by n matrix, right? Yeah. So
Okay.
so it's for a row in size and for column in size, right? So one thing I'm gonna start here and go matrix. Actually, let me not. Should I call it matrix? I'm gonna call it matrix. Equals to that, right? And then I'm going to actually try something else here. I'm going to use I and J, where I represents the index for the row and J represents the index for the column. Is that fine?
Yeah.
Because I want to use row here, row for row. I want to use row there, and then here inside here, for each row we want to append. That, right? Right. And then, are we done or not?
Wait.
We're not printing, we're generating it and returning it to the outside.
So return row.
Return row. Want me to return row? We're here.
No, not there.
Wait.
in the first for loop.
Let me return a row.
Out of the first.
First for loop. Yeah.
Yeah. Oh, wait.
Why are you returning?
No, that, yeah, where you had it previously is fine.
Okay.
Wait,
Yes.
after returning it won't go again to that for loop, or
No, it won't.
or then return won't work
Yeah, it won't work.
because it will do one row and then stop there.
Yes.
Okay. Oh. If you put it outside,
Yeah. You want me to tell you want to test it out?
go on, yeah.
Okay, we're gonna test it out. Print. Want to generate a 3x3, right? Let's see what we get. We get that. Yeah.
One row. Back.
Okay. Wait. Print row in that first for loop.
So you want me? Yeah, you want me to print row here?
No. Where it's return, let's print there. Where it's return, let's print there.
I mean, it's the same thing. Is what you want to do is the same thing we're doing here. So it'll be the same as that. Yeah.
But isn't it after?
Confused as to why
You're confused? What?
we're printing a row.
Oh, what do you want to do? I'm just following what you guys are saying.
Shouldn't we be printing the matrix?
Okay. So you can print the matrix. Yeah. You want me to print the matrix there?
No, or return the matrix.
Okay. You want me to return the matrix?
Yeah.
Okay.
Remove the
So
print.
okay. Remove the print and run it again. So it's empty.
My goodness. So we weren't appending the matrix.
Yes. So what do we need to do now?
We need to append the matrix in
Where?
the second for loop. Go backwards a bit.
Yeah.
In the first. Yeah.
Okay. You want
there.
me matrix? Yeah.
Dot append row.
Okay.
Row. Yeah.
Is that fine? Happy?
Let's check.
That's fine. That is fine, right? So to you can say you can do this just so we know that we have the right thing, right? Have that, and then we can just go. You know that this one will visualize it nicely for us, right? Good, right? So one thing, you see this, we have I, we have J there, but we're not using them. You see that? We're actually just using it for iterations, but actually we don't have a use for I and J, right? So when that is the case, you can do, yeah, sorry? You can
Okay, sharp, continue.
So when that is the case, you can use these things, right? Why is this one complaining now? Remove and use whatever. So you can use like I'm just using underscores there. You see that? So that's how it's not wrong when you don't do it, even if you use I and J. Just that it's the general practice around things like this, like I spoke about how when we share code, right, we need to be able to understand the style of programming that you're using. So when I have initially if I come into the code and start looking, I'm like, okay, I see this line already. I know, okay, this guy is not being used, right? I'm expecting this for loop to just be something that just symbolizes repetition, but we are actually not using the thing that helps us to repeat, right? So we just use your underscore. So it's just communication between two programmers or more, right?
Okay.
So yeah, so when I just use underscores like that, I'm saying, okay, these two things are not being used. That's it. Cool, right? So we have our draw state, we have our generate initial, right? Now so that means we have that. Now we have to let's go to our play, right? We want our play. Yeah. How will we use our play? Or what is the logic for our play? Our play function.
Well, we have to describe what are the markers.
Well, no, the play. So the play method. Let's assume when you use the play method, you already know the marker, right?
Okay.
That's what we're assuming. So we're kind of working backwards too. We're kind of working from the end to the initial. So we'll finish with the actual playing of the game when you get your markers. When we don't start there, so we actually started from the last bit, right? So now you already have your slots, you have your marker. So one thing, let me do this. Let me not have the I there. Not have the I there.
Okay.
Yep.
So we kind of need, I don't know, a way to replace those dashes with the user's input.
Okay, so that's one thing that we can do. We need to get an input from the user. So what do we call it? Okay, move. Move equals the input. And then what's the message?
Play your number.
Place your marker.
Yes.
Okay. And then how does that move help us? What is the move? What should the user input as they move?
I think
Yeah.
the index.
Repeat that.
A space in our matrix. So which row and which. So we need to be able to index the row and index the position within.
So we need to get so the move gives us the column and the row and the column so that we can find it. Okay. So what kind of input do we want from our user? In what form do we want the input?
What's the one that replaces though? Is it pop?
No, before that, we want the user. Do we want this to be the user input?
Yeah, it's fine.
Okay. So that means now we have to get our X and our Y from the move, right? How do we do that?
We do, what is that? You say X and Y is equals to move. X, Y equals X, comma Y.
Okay. Yeah.
Is equals to move.
Will that work?
But I think they shouldn't be integers first.
Huh?
I don't know.
You don't know?
No. But I remember you showed us how we separate these things.
Yeah. Because Nati, how do we separate a string into two bits? or 1, 2 or more.
But where did you show?
Square bracket.
Nope, not that way.
X comma y is equal to move xy.
Move what?
I'm failing to find the shanties.
I'm gonna do it. So I'm gonna split it by that, right?
Yeah, I'm thinking of something completely different. Yeah, you're right.
And then now that we
Okay.
have our X and our Y,
So
what are
we
we?
need to
Yeah.
replace whatever is at that position.
Okay, so how do we do that?
We need to say matrix and
It's slots, yeah.
okay.
Yeah.
Square bracket.
Mm-hmm.
But then how do we know that position?
What do you mean? How do we know?
Okay, let's say for example, it's the first one, right?
Yeah.
So it means X would be 1 and Y would be 1. But
Yeah, so it's the index of. So we index the row, then we index the column.
Yeah. But so you want to use, so is X our row?
Yeah. Yeah, let's make X row.
Okay. And then how do I index Y?
Square bracket again.
So you want me to do that. And then what do I do now?
is equals to the
Yeah.
mark.
Yeah. Are you happy with that? So now let's test it out. Let's see. So I'm going to matrix equals to create initial 103. Can actually do this, I guess. Right. And then we have our play matrix. And we use the X marker. So let's say here, let's say actually be at the end of my play, I want to just draw my, draw that, right? We're happy, right? Every time we play, we draw, right?
Okay.
Cool. So you want 1 and 1, boom. List indices must be integers or slices, not string. What's wrong?
Line 24.
Okay.
Line 23. Line 23, we can make
No,
that.
no. Line 24, because you can't
Okay.
convert this into an integer, right? Because you know your string is 1 comma something, or like a number comma a number. So you can't convert that whole thing into a number, right? So you have, because you split your move into your X and your Y. Now your X and Y are strings, but they represent numbers. So we could do something like I, J equals, if you actually never done this before, int X, comma, int Y, right? And then we could use I and J instead of X and Y, right?
Okay.
Cool. So 1, comma 1, we have that. So it did play, right?
Yeah.
It did play, but 1 and 1 is there, right? It says 1 and 1 is there. It's because what is 1? First row. Okay, what's row number 1? Row number 1 is actually the middle row, right? And then what's in that middle row, what's at position 1? It's that middle, is that one, right? Because you know our
indices start with 0.
yes.
We gotta subtract 1 from each index.
So do we do it? Wait, here, you want to go there. -1 and -1. That's what we're going to do. We can do 1 and 1. We have it there. Huh?
Yeah, that sounds right.
Yeah. Okay, now, so let me do something like this, right? We don't have this yet, but I'll do it here. I'll go 1, 1 equals to X, right? And then I'll make my marker O, right? So I go 1 and 1. No, actually here.
1 and 2.
No, that's not what I want to do. 1 and 1. So it made it an O, right? Actually, let me show you what I'm trying to get from this. Hey. Okay, we have, so you see the initial board has an X there already, right?
Yeah.
Because I did this, right?
Yeah.
Now if I go 1 and 1, change it to an O, right? But we just said yesterday we spoke about how we don't want that to happen, right? If a particular spot is occupied, you should not replace it with the new marker, right?
Mm-hmm.
So how do we stop that from happening? So how do we stop? So we already have an X there. How do we stop the play method from replacing our initial X with an O?
If X is equal to, if the play the spot we're trying to play at is already equal to X, then
Or let's say it's unequal to dash.
Yeah. So we have our slot, right? So slot will be this, right?
Mm-hmm.
Yeah, because slot is the marker in that position, right? And then
Okay.
before you change it, you're like, if slot, you said is not equal to dash, right? I don't know why I did that. It's not equal to dash. Then what do we want to do?
You put that slot is question mark.
And then now you want to do that in there, right?
Yeah. Yeah.
Okay, cool. Do you guys foresee another problem or not?
Yes. What happens if it's it's equal, then we need to put an else statement.
Okay. Well, how's an else statement gonna help us? What do we need to do? Huh? So else, what do you want to do now?
Play a game.
You want to play a game?
So I'm not sure how we do that.
You're not sure how you do that, huh?
Yeah.
Slot is taken. Choose a different one.
So how do we do that? What should I say? What should I do? I'm actually going to show you something cool today.
Okay, let's. Shouldn't we say move back to that move input, place your mark?
So you want to do this? You want to do that?
Yes.
Okay. Then what's going to happen after that? Huh?
So you input the number. Okay. No, wait, I don't know the. I think if we just print that the slot is taken, play again, then the.
Pause.
Yeah, ask.
Line 27.
Yeah.
Our if statement says if the slot is not equal to a dash, then we can.
Oh shit! If it's equal to a dash, we can say that. If it's equal to a dash, then we replace it.
Because then that cleans things up.
Yeah. So let's do something cool. So there's a couple of ways to do it, right? Actually, so we could have this thing in a while loop, right? We could have it in a while loop and say while the user has picked something, has not picked something, then we continue asking them for something, right? Like, oh no, what you selected is wrong, then you're gonna repeat, right? What you selected is wrong, we're gonna repeat, right? But I'm gonna show you some, since we already dealt with you see what's happening?
You're replaying the function.
Yeah. So you're calling a function within itself, right? So this is called, I don't know if I've mentioned this before though. It's called recursion, right? Where you have a function call itself, right? So, but one thing you should be careful when you have recursive functions is that it doesn't go like with your loops, you want your loops to end, right? You don't want to have an infinite loop. So this is kind of like a loop, right? Because it repeats itself until something happens, right? Like in here, it repeats itself actually until this is true, because it only calls itself if that's false, right? So if this is ever true, that means that's when our function will run, right? So like if we run this function, it'll ask you, what's your name? Not what's your name, sorry. Place your marker, X, and then we run there, and then we find that, oh, that the slot in that position is taken. Then we go else, we ask them again. So this function goes to the beginning and then starts over, right? It calls itself, and then it'll go to the top of the function, and then it'll start there. It's like it's asking you again, right? And then it goes there, and then replace if ever your slot is empty, then it will replace it, and then if it replaces it, it will not call the function again. It will go to the end of the function, right? Yeah. So I can run that. Says place your marker at, and then I go 1, 1, and then it says place your marker at 1, 1, right? at whatever. So and then if I say 1, 2, then it places it. It replaced it there, right? You see that? But look at that. This thing ran twice, right? It printed our board twice. You see that? Where do you guys think the problem lies? And how do we fix it?
That draw state slots.
Okay. What do you want to do about it?
Put it below, above the else.
Above the else. So you want it to be in here. So you want me to put it inside the other if, inside this if. So after there, you want me to draw there.
Yeah.
Okay. And then should I remove this one? You want that one gone? Okay. Because that's one way of doing it. What's up? What? This guy. Right, and then now, actually, no, let me try it again. So I'm going to go 1.1, 1.1, 1.3. Okay, cool. There, it's fine, right? So we did it that way. Because we know that our loop only ends when we get to that point, right?
Okay.
Yeah. So
I have a question.
yeah, what's up?
How do we call the next player?
The next player. That's the play method does not care about that. Because it already takes in the matrix or the slots and the marker. So the marker is the player, right? So player 1 will be marker X and player 2 will be marker O. So when you call your play method, you already have that information. So the play method does not need to care about that. Yeah. So that will come somewhere in here.
The tic-tac-toe logic.
Yeah. So we've tested that out, and then we have our three math functions, and then now it's on you guys to complete that one. So yeah, so you need to think about it. So that's for Monday.
Now let's do that thing before you forget. Ne?
Yeah. Huh?
That git.
Yeah. So I just pushed this up so you guys can pull it down. So I'm gonna stop recording now. Stop presenting. Stop recording. Cool.